guys, welcome back. So what we're looking at today is 3.7. So let's go ahead and jump right in. Now 3.7, I will tell you, is the last one of the chapter. So this is a bit of a review. So the book kind of does this sometimes. The last section of the chapter tends to be culmination of everything you've done so far within this chapter. So you're going to see a lot of problems that we've seen before, just obviously different numbers, things like that. But it's going to be a bit of a review, so prepping you for your review and test, okay? So for this first section, we want to determine the domain and range and whether or not the relation is a function. So when we have a function, that means for every x value, there is only one y value, okay? So as long as that is the case, as long as for every x value, there is one y value, then it's a function. Now, if for one x value, we have two y values, then it's not a function anymore. So we're going to look at number 2. So we have 9 and 2, 0 and 4, 4 and 0, 5 and 3, 2 and 7, 0 and -3, and 3 and -1. Now, for each 0, for each x value, is there only one y value? So for each of the first numbers, is there only one of each of those? Because remember, in an ordered pair, x is first. No. So we have 0, 4, and we have 0, -3. So there are two y values for the same x value. So is this a function? No, it's not. Now, even though it's not a function, we can still state the domain and range. So the domain, remember, is your x values. So x values. So we just list out our x values. So we've got 0. Sorry, I don't know why this likes to do that, the random extra lines. 0, 4, oops, 4 is not next. Typically, we want to have them in numerical order. It's not necessarily required, but we do tend to like to have them in numerical order. So we got the 0, we got the 2, next is 3, then we have 4, then we have 5, then we have 9. Once again, sorry about the weird extra lines. Now for the range, that's our y values. So for this, same thing, we look to the lowest, we're at -3. We have -3, -1, 0, 2, 3, 4, and 7. Now, another way to tell if you have a function or not is, notice our domain has 1, 2, 3, 4, 5, 6 values in it. So it has 6 elements, whereas our range has 7 elements. So the range has more values than the domain because the 0, we don't write the 0 twice because it's the same value. So we only write it once. We never write it twice. So if there's a difference between your domain and range, if your domain is smaller than your range, it's not a function. Now, it's okay if your range is smaller than your domain. That just means multiple x values have the same y value, and that's okay. But the opposite is not true. If the domain is smaller than the range, it is not a function, okay? And so that's also why writing the numbers in numerical order makes it a little more helpful to see our values and see how they compare. All right, the next section, determine the domain and range of each of the given functions. So we're going to do number 5 together. So domain, remember, domain is our x values. So this is over here at a -5. So domain starts at -5. And this part of the function goes all the way to 0 on the x-axis. Then the second part of the function starts at 2, and it goes all the way over to 8. So there's our domain, -5 to 0 and 2 to 8. Remember, it's your x values for domain. Now our range, what is the absolute lowest this entire function goes? Well, that's down here at -3. And what's the highest it goes? That'd be up here at +3. So our range is -3. That's a 3 with a random line through it, sorry. Is -3 to +3, okay? All right. We'll do a couple, or at least one more of these. So here, we don't have a graph, but we're still looking for our domain and range. So this is a linear function. Linear functions go on forever. Use that to help you solve your domain and range. This is a geometric function. So remember, it's a curve. Curves, yes, they go on forever, but they have a number that they approach. So that affects our range. Now, our domain, we're going all the way off into the distance, both to the left and right. So -infinity to +infinity is our domain. The range, we're approaching a certain value. Now, in this case, there's nothing added on here, so that means the value we're approaching is 0. So the lowest this can ever go is 0. It's going to approach that, but never actually reach it, and then it's going off to infinity, okay? Now, when you have a table, list out your x values for your domain, list out your h of x values for your range, because this represents y. H of x is y, okay? So keep that in mind when you're doing this one. You're going to list out every single number, okay? All right, and maybe if this will scroll. Hang on. Now we want to determine the domain and range and then determine, we're going to focus on just determining whether or not it's a function. So you don't have to worry about the domain and range. You're just going to worry about whether or not this represents a function. So we're going to do 9 and 12 together. So the distance a person is from the ground related to time as they ride a Ferris wheel. So if we think about it, at each moment on the Ferris wheel, we're getting further and further and further away from the ground until we reach the very top. Then as we come back down, we're getting closer and closer and closer and closer and closer. So is there a relationship there? Is that a function? Yes. So function. For 12, a person's name and their phone number. Is this a function? For every person, do they have just one phone number? Now, some of you may be saying yes. I mean, for me, I've had one cell phone number my whole life, but not everybody does that. Some people may have different phone numbers as they go from one plan to another, or different situations arise and they have different plans. Some people have a work number and a cell phone number, or even a home number. So they have multiple phone numbers for one person. So as a result, it's not a function because there's not just one unique relationship there of, okay, this is my name, this is my phone number, that's all it's ever going to be no matter what for the end of time. That may not always be the case for every single person. Some people have multiple phone numbers because they have a job where they have a phone for that job, or they get multiple phone numbers over the course of their life. I know people who've had 5 or 6 different phone numbers in their lives, and that can happen. So that is not a function because the phone number represents our y value, whereas our name represents the x value. So this is not a function because we can't have more than one y value for every x value, which means we can't have more than one phone number for each person's name. But we know that there are people who do, which means this is not a function. Okay? All right, the next section. So determine the features of functions. So for these next 3 problems, we have different things going on. So in this one, we're looking at the graph where you're going to state the interval where it's increasing and decreasing, identify the minimum and maximum, state the domain and range. So that's what we're looking at on this one. The next one, you'll be looking at a situation and answering questions based on what's given to you in the situation. And then the last one, you have 2 graphs, 2 equations graphed on the same coordinate plane, and you're answering questions about adding them together. Don't worry, you don't actually have to add them together. So we're going to look at number 14 here. So for the increasing interval, so where it's going up, So if we look, we're starting here at -5. We're going down, 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 down until we get to x equals 3. Once we're here, then we start the curve back up all the way until our function ends at 15. So it's increasing from 3 to 15. That's supposed to be 15, now 18. We'll just leave it like that. There should be a parenthesis on the end, but I'm not going to fight it. Now, for the decreasing, so where it's going down, well, that's where we started. It starts at -5, and it decreases all the way to 3. Now, the maximum and minimum. So the maximum, highest point it ever reaches, would be up here at 8. And that's at x equals -5. And that is an x there. I know it looks weird. The minimum, so the lowest point, would be down here, because that's where it gets to the bottom, and then it starts going back up from there. So right here at x equals 3, and it's at -3. So our minimum is -3 at x equals 3. Now, the domain and range. So domain, remember that's our x values. Furthest to the left we go is -5. Furthest to the right that we go is +15. Our range, the lowest point, so look at our minimum, the lowest is -3. The maximum point is 8. So using your minimum and maximum can really help you do your range for this. And looking at your intervals can help you do the domain. So intervals for increasing and decreasing, those can usually help you with figuring out your domain. All right. So your keyword for this lesson is function. Function. If you guys have any questions, feel free to ask. Hope you guys have a great day. Bye.